Okay, so I'm going to start out for this worksheet by finding the accumulated area of this graph, or at least find the area of the pieces before we go ahead and answer the questions that you guys had for these. So I'm going to split this up into a triangle and a rectangle. Next will be a semicircle here. Followed by a triangle. And then lastly, another triangle. So if I find the area of all these pieces, I'm going to have 1/2 my base, which is 2, times my height, which is 2. So this would be an area of 2, and it's underneath the x-axis, so it's negative. This rectangle has an area of -2 times negative 2 times 1 there, so that's going to be an area of 2, and it's also below the x-axis, so that's also -2. My quarter of a circle here would be 1/4 pi times my radius squared. So that's going to give me just pi. And again, it's below the x-axis, so it's negative. I've got a triangle here, 1/2 base, which is 2 times my height of 1. So that's going to be +1. And lastly, my triangle, 1/2 base times my height of 3. Nope, it's 2. So this would give me -2 as well down there. Okay, so now if I go answer the questions that we were struggling with, number 7 says we're going from 6 to 0. Now that doesn't make sense in terms of reading from left to right, so we're going to flip-flop this around using one of our properties. This is the same thing as -0 to 6 of f of x dx. So if I go back and look from 0 to 6, I'm going to accumulate all the area underneath those curves. So from 0 to 6, I've got -pi plus 1, and then I've got a -2. So that's going to give me -pi minus 1. But it's negative, so I've got negative, and then it's a -pi minus 1 was the area that was accumulated. And since I've got a negative there, I can distribute that. So that's going to give me +pi plus 1 for that answer. Okay, number 8 was also another question that we had. So we're going from -2 to 2 of our function. So if I go back up here and look at my graph, I am looking from -2 all the way to +2. So all of that area down there is going to be negative, and I need to specifically find what is this going to be equal to. Well, I can find the area of this triangle, this smaller triangle here, and then subtract it from our area of 2. So this is going to be 1/2 times my base of 1 and my height of 1. So this little triangle is equal to 1/2, which means if the big triangle was worth 2, this part here in pink left over, this piece right here, would be 3/2. So I've got a -3/2, a -2, and a -pi. And if I add all those things together, I would end up with -7/2 minus pi. Okie dokes, moving on now to number 13. Number 13, we're going from 6 to -4, which doesn't quite make sense. So we need to flip the order of that, because we want to go from -4 to 6, and that would make this negative. And now to solve this, we're actually given this information above that we need to use. So from -4 to -1 of f of x, that's equal to -7. The next one is from -1 to 6. That's going to equal 3. That's the accumulation. and then from 4 to 6, that's equal to 6. So if I want to think about splitting this up here, I'm going from -4 to +6. So I can think about, I'm going from -4 to -1, and then I'm also going from -1 to +6. If I put those two things together, that would be the accumulation from -4 to +6. So your answer here is going to be -7 plus 3. And if I simplify that, that's going to give me -4, which is actually equal to +4. Okay, so if I look at number 14 here, number 14 says we're trying to find the accumulation that goes from -1 to +4. Now, if you look at the stuff that we're given, we're not given anything that goes from -1 to +4. However, we do have a function that starts at 4 and goes to 6. That's equal to 6. And we have a function that goes from -1 to 6, and that gives us 3. So that means basically from -1 to 6, the entire accumulation is 3. But then the accumulation from just 4 to 6 is equal to 6. So I could think about taking this whole value and subtracting this value to give me just from -1 to +4. So that's the same thing here. We could rewrite this kind of as, so from -1 to +6 of f of x, if I subtract from 4 to 6 of f of x, that's going to give me -1 to +4. So I can just plug in those values of 3 minus 6 and evaluate that to give me -3. Okay, so on this page, the first thing I want to remind us of is that the derivative of the big F is equal to f of x, and we're given the f of x function. So when number 17 is asking us what subintervals is big F decreasing, what I really want to know is where is f prime of x, which is really the same thing as lowercase f of x. Where is that negative? That's going to tell me where capital F or big F is decreasing. So big F is going to be decreasing on the interval from -3 to 2 and from 4 to 6. Where in the interval does big F achieve its minimum value? What is the minimum? And then number 19, where does it achieve its maximum? And what is the maximum value? So we're going to make a little sign chart here. When I make my sign chart, I'm going to plug in those critical values of -3, 2, and 4. And I'm just going to label whether that first derivative is positive or negative at that point, okay? So in between -3 and 2, that's going to be negative. In between 2 and 4, it's above the x-axis, so it's positive there. And then after 4, it is negative. So there is a minimum value at x equals 2. Okay, now it could, the minimum value could also be at either endpoint. So we do need to check all three of those values. So I'm going to also kind of jump down to number 22 as well while I'm working on this problem, because I'm going to evaluate some of these functions at these points. So keeping in mind this function right here of our graph, we're looking from 0 to x. So we're looking from 0 to 2 to evaluate what big F of 2 is. So from 0 to 2 of big F, that value right there is just going to give me -pi. So your big F down here at 2, F of 2 is going to be -pi. Okay, so if F of 2 is -pi, we need to check both endpoints as well. So I need to check at -3, F of -3, and I also need to check f of 6. Okay, so that means for 0 to -3, that doesn't quite make sense, so I need to think opposite. So from -3 to 0 of our function, what would my answer be for that? Well, from -3 to 0, that accumulation there is going to be positive. Well, it is -4 actually, but then I've got a minus minus, so that's going to be +4. Well, -pi is smaller than that, so it's not going to be f of -3. But then if I look at f of 6, that means I'm looking from 0 to 6. So the accumulation there, I would have this as 2. Oh, sorry, that's 1. And then this right here is 2. So if I add all of that together, I would have -1 plus, or minus, actually, minus pi. So which one is technically smaller? Which one's going to be the minimum? Is it going to be f of 2 is equal to -pi, or is it going to be f of 6 is equal to -1 minus pi? Well, it will be this f of 6. It is going to be smaller than f of 2. So I'm going to plug these values in as well to my f of x function down here. So f of -3 is 4. And then f of 6 was -1 minus pi. Okay. And then if we were doing number 19, again, I would check both endpoints. But then if we're looking at a maximum value, we're looking at where is our big F's first derivative, which is our little case f of x function. Where is that changing from positive to negative? So 4 would be the point that we would test there. And if I actually evaluated f of 4, so I'm looking from 0 to 4, the accumulation from 0 to 4 would be -1 plus, or sorry, -pi plus 4. -pi plus 1. Okay, number 20 was the next question that was asked, and that is about where is it concave up for big F? Well, concave up is about my second derivative. My first derivative tells me whether something is increasing or decreasing. My second derivative of big F tells me whether it's concave up or concave down. So if I go back up here and I look at the slopes of my first derivative function, that's going to give me where my second derivative is going to be concave up or concave down. So all of these slopes here are negative, then they become 0, and then these slopes would all become positive. They're still positive, and they change to negative, and then that's all the way down. That's going to give me negative. So it's going to be concave up where it is positive. So we're going to have concave up from 0 all the way to 3. Okay, and the last piece here is to sketch a rough graph of big F. So what I would do is I would just find all these points by using your graph up above and then plot those values. So I already did a few of them, but let's just continue them. So if I'm looking for big F of -2, technically that means I'm looking at from 0 to -2, or sorry. I'm looking from -2 to 0. That would be negative. And if I evaluate that from -2 to 0, that's going to be an area of 3/2. So I'm going to have, it's already negative, so it's a negative 3.5, or sorry, 1.5. So that's going to give me a positive 1.5 for big F of -2. If I evaluate at -1, that means I'm going from -1 to 0 of f of x, but my function is going to have to be negative there because we flipped the order. So if I look from -1 to 0, that would be an area of -2. but it is negative in front, so negative negative 2 is going to be positive 2. And my apologies, this should have actually been negative 3.5. Okay. F of 0, if I go from 0 to 0, I'm not accumulating anything, so it'd be 0. If I go from 0 to 1 of my function, looking back up here, going from just 0 to positive 1, it's going to be kind of a weird one there. So maybe let's just skip positive 1. Let's go straight to 2. Okay, so we'll skip 1, but at 2 we know it's at negative pi. If I go to 3, that means I'm adding just half of that area of a triangle of 1, so that's going to be plus 1/2. So negative pi plus 1/2. And then lastly 5. If I add up to 5 over here, that's going to be an area of 1/2 as well. So I would have a 1 and a negative 1/2, so that's positive 1/2, and a negative pi to give me, again, negative pi plus 1/2. Then I can just go ahead and plot these points on here. So I got negative 1, 4, negative 2, 3.5, negative 1, 2, 0, 0. We skipped 1, so we're at 2, and then negative 3.14. And then at 3, we're at a little bit less than that, because we're adding a 1/2. And then we added a 1, so we're a little bit higher. Back down to that 1/2. And then at 6, we're subtracting 1, so we should be down below 4. So that's kind of what our sketch looks like. It's not going to be perfect, but you get the idea. Okay, hope this helps. If you still have questions, please let me know.